In this video, we're going to talk about the relationship between a normal distribution with mean mu and standard deviation sigma, and a standard normal distribution with mean mu 0 and standard deviation 1. So a standard normal distribution is a normal distribution that has mean 0 and standard deviation 1. And recall that in a standard normal distribution, data values are already z-scores, because a z-score is the number of standard deviations that a data value is above or below the mean. So if we're talking about the standard normal distribution, the mean is 0. It is 0 0 is 0 standard deviations above the mean. The data value 1 is 1 standard deviation above 0. 2 is 2 standard deviations above 0, and so on. So we also know a way to convert any data value on a regular distribution into a z-score. And that was this formula right here. Z is the data value minus the mean divided by the standard deviation for that distribution. That is a z-score. And so what z-scores do is take any data value, say on this normal distribution, the data value 85. Well, that's the mean plus 1 standard deviation, and taking that z-score would bring us down to a value of 1 on the standard normal distribution. Similarly, if we look at, say, 70 is 2 standard deviations below the mean for this distribution. The mean is 80. 80 minus 2 times 5 is 70. And taking that z-score would bring us down to a -2. Let's just see that in action for a reminder. If we did the z-score for 70 on this distribution with this mean and this standard deviation, that would give us 70, the data value, minus the mean is 80, divided by the standard deviation, that's 5. So we would have 70 minus 80 is -10 over 5, and when we divided, -10 over 5 is equal to -2. So that 70 gets converted to a -2 in the standard normal distribution. Similarly, if we have this other distribution that's a little bit more spread out, here we've got a mean of 15 and a standard deviation of 10. So -5 is 2 times 10 below the mean. 15 minus 20 is -5, and that again would correspond to a z-score of -2, whereas say 25, this is 1 standard deviation above the mean, 25 plus 10, and that would correspond to a z-score of 1. So z-scores take any normal distribution with any mean and any standard deviation and map it onto a standard normal distribution with mean 0 and standard deviation 1. And because these are all normal distributions, they have the same shape aside from their means and standard deviations. So they have the exact same allocation of their probabilities once we do these z-scores. So for example, if we're asked about the heights of adult men in the US, and we say that they're normally distributed with a mean of 69 inches and a standard deviation of 2.8 inches, if one adult man is randomly selected, what is the probability that he's less than 6 feet tall or less than 72 inches tall? So this is a normal distribution because we say that these are normally distributed with a mean of 69 inches and a standard deviation of 2.8 inches. So here is that normal distribution right here. And we were asked, what is the probability that he's less than 6 feet tall? So what we can do is take a z-score. Z, again, is the data value minus the mean divided by the standard deviation. And so in this case, our data value is 72 inches. So 72 minus the mean for the distribution. For this distribution, the mean was 69 inches, divided by the standard deviation for this distribution, 2.8 inches. And when we subtract and divide, we'll get a z-score of 1.07. So this 72 inches, so let's do another color, 72 inches right here is going to map down to a z-score of 1.07, and that makes sense intuitively. 72 inches is just over one standard deviation above the mean, so it makes sense that this would correspond to a z-score of just over 1. And so, now we know. In previous videos, we figured out how to find probabilities for the standard normal distribution, and we could either do that with a table or with a computational device. And basically, the probability that we are less than this value of 1.07 on the standard normal is equal to the probability that we're less than 72 in this distribution. So in other words, the probability here and the probability here are equal. The probability that x is less than 72 in this distribution is equal to the probability that z is less than 1.07 in the standard normal distribution. So this is how we'll approach these problems, especially if we're using the table. If we're using a computational device, we don't necessarily need to find the z-score, but I still want you to understand the connection between a standard normal distribution with mean 0 and standard deviation 1, and other normal distributions with mean mu and standard deviation sigma. So in the next videos, we're going to show how to find these probabilities for any distribution using a table or computational device.